Good morning, children. Saram. Children, today I'm starting with the next portion of the chapter alcohols, phenols and ethers. I'm starting with the ethers. Now, children, we have already discussed that ethers are those organic compounds which have the general formula R, O, R. Here the two alkyl groups can be similar, they can be different also, and the two can be aryl groups also. Example is CH3OCH3, that is methoxymethane. Actually, ethers are the functional group which are the derivatives of alcohols. Now we have to first discuss the methods of preparation of ethers. Now children, the ether can be prepared by the dehydration of alcohol. We have already done this reaction in the previous session, in which alcohols are dehydrated at a temperature of 443 Kelvin in presence of sulfuric acid, which is a very good dehydrating agent, and result in the formation of an alkene, that is acid catalyzed dehydration of alcohol to form an alkene. This we have done in the previous session. We have done the mechanism also. Now, if the same reaction is carried out at a temperature of 413 Kelvin, the reaction will not give an alkene. Instead, it will give an alcohol. You have the mechanism also of this reaction in your syllabus, in which in the first step, the protonated alcohol is formed. That means the alcohol reacts with the proton and the protonated alcohol is formed. In the second step, another molecule of alcohol reacts with the protonated alcohol and forms protonated ether. And in the third step, the protonated ether undergoes deprotonation. That means a proton is given out and result in the formation of an ether. So the reaction is same. You have to remember that if the temperature is 443 Kelvin, then it will result in the formation of an alkene, and if the temperature is 413 Kelvin, it will result in the formation of an ether. Now, why it happens? It is because one more thing you have to remember first, that this method, it is suitable for the preparation of ethers having primary alkyl group only. Why? Because the primary alkyl group, it is unhindered and the temperature it is kept low. Now in this condition, the reaction favors SN1 pathway, and when the alcohol is secondary and tertiary, that you'll learn in higher class about the secondary and tertiary alcohol, they'll give corresponding ethers, that this reaction will be unsuccessful, where elimination competes over the substitution reaction. Now, another method that can be used for the preparation of ether is the Williamson synthesis of ether. In this Williamson synthesis of ether, the very important thing that you have to remember is that this method of preparation of ethers is for the preparation of symmetrical and unsymmetrical, both type of ethers. But in the previous one, this first method of preparation, that is by dehydration of alcohol, can result in the formation of only the symmetrical ether. So when we have to prepare symmetrical ether, we can use the first one, and when we need to prepare the unsymmetrical ether, you can use this Williamson synthesis of ether. It can be used for symmetrical ethers also. Now in this method, what happens? An alkyl halide like RX reacts with sodium alkoxide and result in the formation of an ether. Now children, you have to remember that the alkyl halide that you are taking in this reaction should be a primary alkyl halide, and the alkoxide ion can be primary or secondary or tertiary. When the two react together, then this NaBr is eliminated out as a byproduct and result in the formation of ether. Now you have to remember that if instead of taking the primary alkyl halide, you take the tertiary alkyl halide and the sodium alkoxide is primary, then the resultant compound will not be an ether. Why? Because when this such type of reaction takes place, then elimination competes over substitution, and the elimination reaction takes place and result in the formation of an alkene. So the alkyl halide should always be a primary alkyl halide. Tertiary alkyl halide will not give an ether. Now some questions are there. The following is not an appropriate reaction for the preparation of tertiary butyl ethyl ether. What would be the major product of the reaction? Now the major product for this reaction will be an alkene. Why? Because the alkyl halide that we have taken here is not a primary compound, it's a tertiary compound, so the product form will be alkene. Now the second part of the same question is write a suitable reaction for the preparation of tertiary butyl ethyl ether. So what you have to do is you have to take the Cl in place of ONA and this ONA in place of Cl. So this will be the reactants. Now next is phenols can also be converted to ethers by the same method. Phenols can also be converted by this Williamson synthesis of ether, in which first of all we take sodium phenoxide and we take an alkyl halide. The alkyl halide, you have to remember, should be a primary alkyl halide. It will result in the formation of an ether. Now coming to the physical properties of ether. Now children, as you all know that the CO bond in ethers are polar. The carbon oxygen bond is a polar bond because of the electronegativity difference between carbon and oxygen. So they have a net dipole moment. Now this weak polarity of ethers do not appreciably affect their boiling point. That means there is no effect of polarity of ethers on the boiling point, and the ethers have boiling point lesser compared to the alcohols, but have boiling point lesser compared to the alcohols and have a much lower boiling point than you can say the alcohols, but are of comparable values along with the alkyl halide. That means there is not much difference between the boiling point of not alkyl halides, the alkanes and the ethers. They have almost similar boiling point if the molecular mass is similar. Now alcohols have very high boiling point compared to the ethers. It is because of the hydrogen bonding. Next is the solubility of ethers in water. Now ethers in solubility they resemble the alcohols because ethers can also form a bond with water. Now if we compare both ethoxyethane and butane 1-ol, they are miscible to almost the same extent in 100 ml of water, while the pentane is essentially immiscible in water, which is an alkane. It is just because of the fact that oxygen and ether can also form a hydrogen bond with water. Oxygen of the ether is forming hydrogen bond with water, so they are miscible in water in the same proportion and as alcohols are there. Now the next thing we are starting with is the chemical reactions of ethers. Children, first thing you have to remember is ethers are the least reactive of all the functional groups. Their reactivity is very, very less. Now the bond between carbon and oxygen in ethers, it breaks under drastic conditions and excess of hydrogen halide. That means when ethers react with hydrogen halide, they result in the formation of alcohol and alkyl halide molecule. The same reaction in case of alcohols was much easier. Now, if we talk about the aryl alkyl ethers, then the cleavage of alkyl oxygen bond due to more stable aryl oxygen bond takes place. That means this bond will break, because this bond has a partial double bond character, so it will not break. So the benzene ring will result in the formation of an phenol, and the alkyl part will give you the alkyl halide. Now, if suppose we have the unsymmetrical ether in which both the parts are the alkyl group, then here also the cleavage takes place in the same manner, that the order of reactivity, the cleavage takes place in the same manner. One of the part result in the formation of alkyl halide and the other part result in the formation of an alcohol. Now children, you have to remember, if the halogen part here is iodine, then the bond is longer, it can break easily. If it is chlorine, the bond is shorter and stronger, it will not break easily. Now children, see, if suppose one of the alkyl group here is a tertiary and the other one is primary, then which one of the two bond will break easily? Now this CO bond will break or this CO bond will break. It depends upon the, you can say, the plus I effect of CH3. Now you all know that when the bond between carbon and oxygen is breaking, then carbon is having more electron density because of the presence of 3 alkyl groups, which are the electron donating group. So it will result in the formation of more stable carbocation, and the reaction will follow SN1 mechanism. That means the bond between this carbon and oxygen will break. Next is the electrophilic substitution. Now you all know that the ortho and para positions in the benzene ring in the ethers is negatively charged, because the oxygen of ether is electron rich. It will supply electrons to the benzene ring, so the ortho and para position become electron rich. Now when the halogenation takes place, in presence of ethanoic acid, then para-bromo and ortho-bromo anisole are formed. Now the para product is major product because of the symmetrical reason. Next important reaction is the Friedel-Crafts reaction. Now what happens in Friedel-Crafts reaction? Alkylation and acylation. Alkyl group is added at ortho and para position in presence of anhydrous AlCl3. Acyl group is added at ortho and para position in presence of anhydrous AlCl3. Now the major products are always the para products because of the symmetrical reason. Now the name for this compound, the para major product, is your 4-methoxytoluene, and for this compound it will be 4-methoxyacetophenone. Similarly, another example of electrophilic substitution reaction is the nitration. Now nitration takes place in presence of sulfuric acid. Orthonitro and paranitro anisole are formed. Now children, question is here, in which write the reaction for Williamson synthesis of 2-ethoxy-3-methylpentane starting from ethanol and 3-methylpentane to all. That means 2 alcohols are there. You have to make them react with an alkyl halide and you have to form the ether. Second is, which of the following is the appropriate set of reactant for the preparation of 1-methoxy-4-nitrobenzene and why? Now you have to tell which one is appropriate. Here the alkoxide ion taken is primary, but the alkyl halide taken is not primary. Here is the alkyl halide taken primary, so we have to take the primary alkyl halide. This will be the appropriate reactants. Next is, predict the products of the following reaction. This. what will happen? Which bond will break? In which most stable carbocation will be there? So this bond will break. Now next is, children, you can do it yourself. It is electrophilic substitution reaction. Nitro group will be added at ortho and para positions, and you can do all these reactions yourself. So your alcohols, phenols and ethers chapter is done. Now in the next presentation we'll start with the third chapter of your organic chemistry, that is the carbonyl group containing compounds like your aldehydes, ketones and carboxylic acid. Thank you and Sairam.